Okay, gentlemen, we're going to be looking at rational expressions today. Rational expressions are, as we list right here, a fancy word for just a rational number, right? Like fractions, except instead of the numerator and denominator being numbers, they're actually polynomials. So like the stuff we've been just spending a lot of time on with factoring. Okay, so if we're good at factoring, this should be pretty straightforward because fractions are something that we've done before in middle school most likely, and we kind of understand the concepts of it. But there's this added part about domain, right? We had talked about it very, very briefly in the beginning of the year, so I don't know if we remember exactly what domain is. But it is the set of real numbers that define an expression, or in other words, the way I phrase it is like the values that we are allowed to use as inputs of a function. Okay? We're going to talk a lot about that because that's functions is what trimester 2 is about, and that's really what the whole course is kind of focused on. So we want to make sure we understand domain because we want to know what are we allowed to use, and then in calculus we kind of play with our functions a little bit, see what happens with them, graph them, and we understand what the points mean. But we got to know what we can use before we can figure out what it does. Okay, generally 2 rules. Radicals must always remain positive. We know that because we know negatives are imaginary and those are not graphable. So we don't like to make those happen. It's not in my domain. We're allowed to use imaginary numbers. If we get an imaginary number, that's fine. We know how to do it, but our domain has to be a real number, and imaginary numbers are not real. Okay? Fractions, we must never divide by 0. Never divide by 0. So just some examples. What are the domains of these? I'll always write the domain in red. That's how I do it, so that when you're looking at notes and homework, everything always has like domain in red, then all the other work is usually in blue or something like that. So the domain of pretty much any polynomial, binomial, anything that looks like this is going to be all real numbers. In other words, all real numbers, right? And that's what we mean by we cannot have imaginary. So negatives and radicals would not be good. All real numbers. So it's anything that's not a radical or not a fraction. These are where we're going to have exceptions. But if it's anything that has no radicals in it, is not a fraction in itself, would be deemed all real numbers. If I took this and wrote 3 over 2 and 5 over 2, that would still have the same domain because there's not an x as a denominator of the entire fraction. 2 and a 5 has no impact on domain. It's just coefficients of x squared and then your back number. Okay, so that's kind of the description there. I'm actually going to we'll do this one next because it's actually a little bit easier. So first of all, you cannot cancel out those x's. Cannot do that. You need to cancel it out if it's in every term. So this has to have an x, it does. This has to have an x, and then this has to have an x, it doesn't. So you can only cancel out things if it's in every term. Only cancel out if in every term. Okay, so you can only cancel out if it's in every term. Okay, so looking at example 3, what would be the number that when I plug it in would make me divide by 0? What's the number that would make me divide by 0? Essentially, kind of the way to look at this is take the denominator. I'll do that in blue to keep it consistent. Take the denominator and say, what would it have to be that I would get 0? What would I plug in to get 0? Well, it's kind of easy to see. 2. If I plugged in a positive 2, I would get 0. So kind of the idea being is that I must never divide by 0. So looking at the bottom, if I set it equal to 0, that's the number. When I plug it in, that will give me 0. So 2 is the number that I cannot use. So basically what we want to say is my domain is all real numbers except 2. But there's got to be a better way to write that. And I'll show you the better way to write that. All real numbers except for the number 2. All real numbers except for the number 2 is my domain. Because that's the only one that's not good. That's the only number, when I plug it in, will give me 0 on the denominator. Top doesn't matter. Okay? Now, we saw interval notation as this. Soft brackets for infinity always. Soft brackets for infinity always. But now, is there a way to say this and then say, like, except for 2? Like, is there a way to say that? Of course there is. A little weird looking, so we're going to practice it as much as we can. Okay? You're going to say negative infinity up until the number 2 with a soft bracket. Meaning you don't get to be the value 2, you just get very, very close to the number 2. Okay, so it's from negative, think of a number line, from negative infinity up until 2, but don't actually get there. And then right after 2, pick back up again. Since they're both soft brackets and it's the same number, that means skip the number 2. That means skip the number 2. Okay, now most of you have not seen that before. Maybe even all of you have not seen that before. So I know it looks a little weird, but how do you say like and, right? How do you say and both of those things? From negative infinity up until 2, and then on the other side of 2 to infinity, right? And the soft brackets means you're not going to become 2 on the left side. You're not going to become 2 on the right-hand side. We union the two sets. It's called a union of two sets, of both sets, right? So the U is the union. It's just a big capital U. That's new. We're going to try that on the homework, right? And my answer key will always write my domain in this form, okay? We may not get it all right today. That's fine, but we want to start to get the hang of it, okay? Let's do the radical one, then we'll do some examples. Okay, domain here. So we can't have negatives in radicals. So what we want here, right, is no negatives. Just like I did down below, essentially what you're saying is x minus 1 must be greater than or equal to 0, right? It has to be positive. That has to become positive. That has to become positive. And an important fact is radical 0 is equal to 0. That's okay to have. I'm not allowed to have 0 down here, but I can get 0 inside a radical, and I want everything bigger than that. I want to become 0 or be larger than 0 too. I could be 1 or 2 or a half. I could be larger than 0, and I can be 0, but I have to make sure I'm not less than that. Okay, and if we kind of solve this, we get x is greater than or equal to 1. Think about that. You plug in 1 minus 1, that's 0. Plug in 1.5. I'm going to get square root of 0.5, that's fine. Plug in 2 minus 1 is 1. All good. If I plug in 0, if I plug in 0, I get a negative number, so that's no good. I got to be at least 1 or larger. At least 1 or larger. We know how to transform that into interval notation. We've done that a lot. It's greater than or equal to 1. 1 or larger. Always get a soft bracket on the infinity. And now you have a hard bracket on the 1 because it is or equal to. So there's my domain there. So the way to think about it for radicals is greater than or equal to 0. You take the radicand and whatever's in there and set it greater than or equal to 0, just like I did here. And then on fractions, you take whatever the denominator is and you set that equal to 0, and you're solving, and then that tells you, this is my denominator, I set it equal to 0, and that helps you find the value. Okay? We'll jump to some examples. You have some for homework. I'll be back next time. We'll review it all. We got Thanksgiving. We're doing this till our next test, practicing a lot. So we're going to keep going from there. Okay, reducing the rational expression is simplifying it, okay? So we can cancel out factors, and that's exactly what I meant up here. Only cancel out if it has every term. That's the same thing as a factor, okay? When we find the domain, this is in capital, clearly important. before you cancel stuff out, use that to find the domain. Do not find the domain after canceling out factors. And there's a long discussion about that. I'll do it in class, but not over this. Okay? Easy one. If I were to say 6 over 9, 6 divided by 9, I took off half a point on your test. If you didn't simplify stuff like this, it would be divided by 3, 2 over 3, right? I have a factor of 3 on the top and a factor of 3 on the bottom, so I can cancel it out. Okay, it needs to be present in every term. If I had 6 over 9 plus x, that would be my final answer. I cannot, I cannot cancel these out and say 2 over 3 plus x. Not true. I need it to be in every single term. We had a lot of this discussion, like the plus sign tends to mess things up. Here it is again. Okay? Come on. There we go. Okay, so let's look at this one. So I want to factor the top and bottom. Okay, so I look at the top. It's 2 terms. I can't really do my difference of 2 squares things, but there is an x in both terms. So I can say x and x minus 3. And on the bottom, that looks like something we've done before, x minus 3 and x plus 3. Okay? Now, my domain here, before canceling, would be x cannot be 3 and x cannot be negative 3. Right? I can kind of write that over here. I set both of these equal to 0, each factor. And then I'm able to kind of find what are the 2 values I can't use, right? X squared means I get 2 solutions. There's 2 values I can't use. I cannot use a 3, and I cannot use a negative 3. Okay, so it's almost like when we were solving these for our test. So now I want to say I go up to the first number that comes on a number line. I go up to negative 3. I skip negative 3. Remember, that means skip negative 3. And then I keep going up until 3, and I'm skipping 3, and here is me skipping the number 3. Okay, so that's the domain. I don't ask too many of these kind of like trickier ones. We're going to get up to that, but just kind of to see it now. You could have more than one number you're not allowed on the bottom. You could have 4 numbers you can't use on the bottom. Okay, so anyway, so now we're continuing with our simplifying here. I have 2 of the same factors. I'm able to cancel them out, and I get x over x plus 3. This is my reduced form, but as I highlighted very importantly up here, my domain is based on what I have prior to me canceling. Okay, there's my reduced form. There's my simplified answer. My directions were to say here, reduce the following. There we go, I reduced it. If I ask for the domain, you take the domain prior to reducing. Okay, and you can only cancel out, as I wrote up here, factors. So I need factors. Here's 1, here's 1, here's 1, here's 1. As long as everything's in parentheses, I know that those are factors. They're the same, I can cancel those out. Do another one. I won't do domain here. I'll just kind of do the simplifying. Taking the top 2 numbers that multiply to negative 30 and add to positive 1. 6 and negative 5. And then on the bottom, 2 numbers that multiply to 24 and add to 10. Both positive, so I know that that is an x plus 6 and an x plus 4. It's not a 12 and 2 because I have to get a positive 24 and a positive 10. So 12 and 2 would give me a negative 24. It wouldn't work because one would be plus, one would be minus. So, right, and that's what we need. We need to be able to factor quickly so that doing this to here doesn't take us too long. On our upcoming tests, factoring is going to be a part of that for sure. I would take my domain here if I was asking for it. I'll leave that for now for the sake of the video length. Do I have anything common? Yes, I have x plus 6 in both. X minus 5, x plus 4. Here's my reduced or simplified form. Okay, now remember, I cannot cancel out the x's. It's not in every term. Those are not factors. There's no multiplying here. It's x minus 5 and x plus 4. I cannot cancel those out because there's not an x in every term. Those are not factors. Same for up here. I cannot cancel out these x's for the same reason up here. I need it to be in every term, and it's not. But it has to be factors. There's only one factor here, one factor here. That's not common in every single term. Okay. Operations, quick, just to kind of go over these. I'll do a multiply and a divide because that's what your homework is on, and then I'll do we'll do adding and subtracting next time. Multiply, we want to just multiply the tops and the bottoms. 3 over 5 times 4 over 6, I'll do it over 7. We just get 12 over 35. If we can simplify, we simplify. If we can't, we don't. Done. All right. What we're going to recommend is if I say 3 over 5 times 7 over 6, we could get something like that and say, oh, I got to simplify. It's 7 over 10. If I were to say that 3 goes into that 6 because it's multiply, I can kind of automatically get my 7 over 10. I could simplify first or simplify later. We're going to simplify first because otherwise we'll get huge things we don't know how to factor. Okay? And with dividing, some of the classes did this when we had done completing the square to get the quadratic formula. If I have something like 1/2 divided by 9 over 4. Okay? If we write that as 1/2 times 4 over 9, now it's a lot easier to do. Instead of having to like write it as a big fraction, we're doing a divide. Again, I'm going to try to get into the habit of seeing spots I can simplify before I multiply because it makes the multiplying easier, and then it would be harder for us to factor something with like a big power. We won't know how to do that. Okay? So here's 2 examples. I'll do a divide because it's really the same thing as multiply. And then I'll kind of leave the rest for you to do for homework just so this video isn't so long. Okay. Example 12. I would say in the directions divide the following. Okay, so first when I see divide, I see this sign right here. And I know that means I'm going to flip that second fraction. So I have x minus 2. First one doesn't change. I do, however, change that divide to a multiply, and then I flip the second fraction, just as we saw up above with the basic numbers. Okay? When I'm dividing, we treat it like we do for fractions. We flip the second and multiply. So this is kind of now a multiplication problem, which is why I don't really need to do this one too much. But the idea is the same. I'm going to like factor, then cancel out what I can, and then multiply based on what's left. Okay, so let me factor each part. X squared minus 1. That should be very quick for us to do. I'm factoring it into x plus 1, x minus 1. Down here, I'm looking for 2 numbers that multiply to -2 and add to -1. Well, that's -2 and 1, so I get x minus 2, x plus 1. And I have multiply. Over here, looking for two numbers that multiply to 4 and that add to -4. -2 and -2 work. So I get one of those double roots if I were to do this by the discriminative. And then lastly, two numbers that multiply to 5 and that add to 4, 5 and -1. Okay, so I took each part, factored each numerator and each denominator, just like up here. If I recognize, like, oh, these can cancel out. It's the same idea of me saying 2 times 1 and 2 times 2 and me saying, oh, I can cross off a pair of those 2's. Okay? You can only cancel out with something on the bottom and something on either top, or something on top with either bottom. You cannot cancel out this way. It's got to be from a bottom to either top, or a top to either bottom. Okay, so let's see. I have a -1 and a -1. And again, now these are all factors. Multiply, multiply, multiply. Everywhere. So now I have a bunch of factors. I'm canceling out parentheses. I have an x plus 1 and x plus 1. I have an x minus 2 and x minus 2. And now I'm left with this guy and this guy. Those are not the same. So I have an x minus 2 and an x plus 5. Can I cancel out these x's? No x's can cancel out right here because it's not common in every term. That parentheses is kind of telling me these stick together. So I cannot break into the parentheses. Here is my final reduced answer. Well, I guess not even really reduced. It's just my final, I guess, simplified answer. That's how we multiply and divide. It's the same thing. If I were to multiply this out right here, right? I flipped it. X squared times x squared, I would get an x to the 4th, which we don't know how to factor that. So this would be a very difficult problem to multiply and then try to simplify. You have no idea how to factor it. So it's much, much, much easier for us to factor it, cancel out what we can, and then what am I left with? I happen to be left with just two things. Bam, I'm done. Okay? Again, same as I did last time, here is my assignment. Some of you forgot the heading, so I'm circling it here just to kind of reiterate that. I put it in there for you to write it. Please put your name on it. Domain of these, nice and simple. Simplify the following rational expressions. So again, that's just canceling. I'm not asking for domain here. I may write it on the answer key, but not asking for domain here. Multiply or divide. And we know for our dividing, we flip and we change it to multiply. This is already multiply, no flipping. This is divide. We're going to flip this and change it to multiply. And this is already multiplication, so we're good. Okay? Down here, I have like what we would do next time. So don't worry about that. You're just going to submit pages 1 to 4. And that's all it is. The notes, the work, make sure you put your heading on it. Just submit pages 1 to 4. Do not submit page 5 and on. I don't need that. Just 1 to 4. Okay, good luck. And hopefully I'll see you guys soon.